Hi, sorry we had a bit of a technical hitch up there, so just starting now. Right, so that's not the first question we're going to start off with. We're going to start off with some indices work. Just do some 3 trickier questions. If you find these a bit too tricky, go and look at the 6 to 7 live streams on the same topic from yesterday. So I'll give you 60 seconds to have a go at this one. Here you go. Right, here we are back again. Sorry about that. Right, again, we're going to multiply out the powers. We've got this is the same as 71 to the power of 1 over a plus b. So we have 71 to the power of 1 over a plus b, all to the power of a plus b over b. Now remember, power of a power, we multiply the indices. So 71 to the power of 1 over a plus b times a plus b over b. And if we work that out, we get 1 times a plus b over a plus b times b. And what you, b. And what you can see is we have a common factor, top and bottom of a plus b, which we can cancel. So that just leaves us 71 to the 1 over b. A plus b into a plus b is 1, and that just leaves b on the bottom. So 71 to the 1 over b. Right, another 60 seconds to try and do this one without a calculator. Do not use a calculator on this one. Okay, here we go. So we're going to do 2 to the 3 divided by 2 to the cube root of 2, that is. So this is going to equal to 2 to the 3 over 2 to the 1/3. Remember, cube root means 1/3, and to the power of minus 5/3. Let's work this bit out first. So that gives us 2 to the 3 minus 1/3. to the minus 5/3. Now 3 minus 1/3 is equal to 9 over 3 minus 1 over 3, which gives us 8 over 3. So this bit here is equal to 8/3. So we've got 2 to the 8/3 to the minus 5 over 3. And that's going to equal, times these together, 8 times minus 5 is minus 40. Because we're multiplying these indices. 3 times 3 is 9. So we get 2 to the power of minus 40 over 9. Right, last one of our, I think it's the last one of our indices. Yes, it's the last one of our indices. Another 60 seconds, off you go. We'll stop that early because you either know it or you don't. It's a really quick one. So what we do here is we just multiply the indices. So x to the 3 over 2 times by minus 1, which is just equal to x to the minus 3 over 2. Just make it negative. And that is all you got. It's that simple. So you're either going to see it really quickly and get it quickly, or you're going to get it wrong. Okay, you weren't really going to work that out any faster. Right, let's move on to some algebraic fractions. Let's work these out. Okay, I'm going to give you 60 seconds to have a go at this. See how you get on. There we go. So we've got two fractions, one fraction divided by another fraction. And when we do that, we just turn the second fraction upside down and multiply. We're not going to do many of these today because they're exactly the same as the level 6, 7 ones we did yesterday. So if you need more practice or want to see more examples, go and look at yesterday's live stream. So what we've got here, we've got 2 times 2 cubed, which gives me 4x cubed. And we've got 11 times y squared, which gives me 11y to the 4. And there's nothing that's going to cancel down. No common factors in x and y, no common factors in the 4 and the 11. So that is our answer. Okay, just move on. There's 3 different types for you to have a go at today. If you need any more, we can look at yesterday's ones. Right, let's add these fractions together. We need to get a common denominator. There's no common factors, so the way to get the common denominator here is just to times the two together. So we're going to times top and bottom of this by 5y cubed. So 5y cubed times 3y cubed is 15y to the 4. And we're going to get x to the 4 times 5y cubed on the bottom. On the top, times top and bottom by x to the 4. So we get 4x times x to the 4 on the top, and we got 5y cubed times x to the 4 on the bottom. So it's all over 5y cubed x to the 4. We've got 15y to the 4 plus 4x to the 5. 15y to the 4 plus 4x to the 5. And as we can't factorise this, as I showed yesterday, we're cancelling out, then you can't cancel anything down. There's no common factors throughout the top, and therefore we won't be able to cancel down anything with the bottom. So we just get 15y to the 4 plus 4x to the 5 all over 5y cubed x to the 4. Right, next one. 60 seconds, there you go. did it again. Right, here we go. Got the sound on this time. So let's just do this one. We're going to factorize top. We're going to factorize the bottom. Always start with these questions factorizing the bottom. So if we factorize this, we're going to get on the bottom. We've got 20, so that could be 5 and 4, and you make them both negative, you'll get your 9. Okay, if you don't see it that quickly, then you need to spend more time doing factorizing and go back to yesterday's lesson where we did cover some factorizing and the 6 and 7 stuff. Over here, you've got 5 and 1, so we get x minus 5 and x minus 1. And this is the key trick, is to spot this is in both. So we don't need to multiply that throughout. We've already got it on both. We just need to make sure we get these two. So therefore on this side we're going to times top and bottom by the x minus 1, and on this side we're going to times top and bottom by the x minus 4. So let's do that. So x minus 1 in there, and x minus 1 in there, x minus 4 in there. And so that's all going to equal x minus 5, x minus 4, x minus 1 on the bottom. And I haven't put the x minus 4 there, so let's just write it out. So I get 2 times x is 2x, 2 times minus 1 is minus 2. Minus, be careful, it's very common to forget this minus. So you've got minus 1x, and then we've got minus 4, 1 times 4, that's going to give me a plus 4. So let's work that out. So 2x minus x gives me x, minus 2 plus 4 is plus 2, nothing to cancel. That's why I've left it in the factorized form, so I can easily see if there's a common factor which I can cancel, and there's no common factors. So I'm going to leave that as my final answer. You may multiply out the bottom, I wouldn't bother. It's no simpler or more complex than multiplying it out. But we generally leave things in factor form so that we can spot if there's a common factor top and bottom that we can cancel. Right, another 2 minutes, slightly more difficult factors to find. Off you go. So again, remember, factorise the bottom. So here we've got 18, so what do we get? We get 6 times 3, and they add to give me 9. So x plus 6, x plus 3 on the bottom here. Over here, I've got, I want it 13, 6 and 7, x plus 6, x plus 7. And again, we can see we've got a common factor here and here, so we don't need to times by that. So I'm going to times top and bottom by this by x plus 3. I'm going to times top and bottom of this one by the x plus 7. And then I've got the same things on both the top and the bottom. So x plus 7 there, x plus 7 there, and x plus 3 here, and x plus 3 here. And therefore I'm going to multiply this out on top. So I'm going to start with this side. So that will give me x squared plus 3x. The reason why I chose this side because A gives me the x squared and this doesn't, and this has got a minus, which I tend to like a bit later in the expression. So minus 5 times x is minus 5x, and minus 5 times 2 is minus 10. All over x plus 6x plus 3x plus 7. Simplify the top, we get x squared minus 2x minus 10. And there's another top that doesn't factorise. I'll say my maths are setting up questions you're likely to get in the exam. Normally, this you'd expect to factorise this, okay, and then usually there'd be a common factor top and bottom for you to cancel. But it's obviously concentrating on the technique of spotting the common thing you don't need to multiply by, and then just multiplying by the things you need to multiply on these questions. So keeping it nice and simple. So our final answer remains unchanged. And this one we did earlier, the explanation remains unchanged, exactly the same explanation. There were just slightly more difficult factorizations because there's more combinations of factors you could choose from. Right, now put all that into this. Remember what you did there? See if you can work out how to solve this. I'm going to give you 3 minutes to have a go at this because it's definitely trickier. There's two ways you can do this question. We can do it exactly the same way we did the last question, which I'll show you that first. So what we're going to do is we're going to factorise top and bottom of this, see what we get. We're going to get x minus 7 and x plus 2 will give me that one. And on this one I'm going to get minus 5 and 3. No, I'm not going to get minus, sorry, 2. Stupid me. There we go. And we can get that. And we do exactly what we did last time. We got a common thing, x plus 2, so we need to times by it. And then we've got an x minus 7, and we've got an x minus 5. So we need to times over here by x minus 5 to make it the same, and over here x minus 7 to make it the same. So let's do that. So that's x minus 5 there, x minus 5 there, x minus 7 there, x minus 7 there. So I'm going to put this bit at the front of my fraction. So I'm going to get 2x minus 14 minus another x plus 5 equals 0. And then I'm going to get x minus 7, x plus 2, x minus 5 on the bottom. And the top simplifies to x. I've got minus 14 plus 5. That's going to give you minus 9 on the top. And I'm going to write all this on the bottom. And then the key thing to remember is if this is going to be equal to 0, then the only thing that needs to equal 0 is the top. So therefore x equals 9 is the answer. Okay, I'm just going to... Now, the other way we could have done this, which I'm not convinced is necessarily a good way forward with this question, but it can be sometimes. You could times throughout by this, and you're going to get minus 1 x squared minus 3x minus 10. And then you could times throughout by this, and you get 2 lots of x squared minus 5x minus 14. You get that all equals to 0. And why have I only got that? Well, if I'm timesing top and bottom of this by x squared minus 3x, so I only get the 2. So I don't get this x squared minus 3x minus 10. If I times top and bottom this by x squared minus 5x minus 14, I only get the minus 1. So when I times by this bit here, okay, it will if I times the top by it, then it will cancel. But I need to times by it here, so hence why it ends up over there. And 0 times it gives me 0. And if I times by this, then it's just going to end up here, because when I times top and bottom, it's going to cancel. So I'm just going to get left with it there. And then you can just solve this and you should get the same answer. Let's have a look what happens. So we're going to get an x squared. Actually, let's multiply it out first. Get minus x squared plus 3x plus 10 plus 2x squared. I'm not liking where this is going because I've got an x squared in my answer. I'm wondering why. Okay, let's keep going. See what happens. Minus 10x. And then what we got minus 28 equals 0. So 2x squared minus x squared is x squared. I've got minus 10x plus 3x. That's going to give me, well, I've got to be careful here. Minus 1 times minus 3x. Yep, just checking that. So that's going to be minus 7x. 10 minus 28 14 equals 0. So that factorizes to give me totally different answers. X minus 7 and x, wait a minute, 14 to get 7. It's not going to factorize. Some mistake. Oh, it's 18 there, isn't it? So we get x, work that out. So we want to get minus 7, so we get minus 9 and plus 2. So we've got the x equals 9. I'm just trying to think. Now the interesting thing was the problem with this method, we get also x equals minus 2 comes out. And there's a problem with that. And the problem with that is when you put it into the bottom, because we've got this factor over here of x plus 2, you put minus 2 into it, you get 0, and then this whole thing is undefined. So it can't be defined at x is minus 2, so that will not be a solution. Okay, when you try and put it into here, so that can't be a solution. But x equals 9 can go into all the bottom bits and you won't get a 0 on the bottom, so hence why that one disappears there. So adding together as a single fraction is a much more straightforward way of getting to the answer. So have a go at this one. 3 minutes, off you go. Okay, time's up there. Right, so let's look at this one. We're going to factorise like we did last time. I just thought of some other reasons for the last one, which we'll talk about why it didn't work. We'll look at, for those of you who are really aiming for the top level and want a good understanding of it. So factorise that, x squared minus 4. For those of you at level 8 and 9, this should be quite straightforward. You should know this one. Go back to a previous video on level 6, 7 if you want to know more about it. So here we go, we've got x, what we got, minus 4x minus 2, and again we've got that common factor, so we don't need to times by that, we just need to times by these two things. So I'm going to times this one by x minus 4 on the top and the bottom, and over here I'm going to times by the x plus 2 top and bottom. Okay, e equals 0. So I multiply at the top. I'm going to start off over here. X squared plus plus 2x. And over here I'm going to get 4x. 4 times minus 4 is minus 16. All over x minus 2x plus 2x minus 4 equals 0. And now I've got, what have I got? I've got x. All I need to know is at the top of this here equals to 0. So we'll simplify our next line. So we get x squared plus 6x minus 16 equals 0. And what we got, 8 and 2 works with this one. So we get x plus 8 and x minus 2 are our factors for this. So therefore x will equal minus 8 or plus 2. Remember, reason for that is either this equals 0 or this equals 0. So if x plus 8 equals 0, then x must equal minus 8, and x minus 2 is equal to 0, then x must equal 2. Going back to that previous question, another reason why this doesn't work with the x equals minus 2, there's a mistake in mathematically in what we did here, because we've effectively, if you times by this, you've got an x plus 2 as a factor on the bottom, and you've got an x plus 2 as a factor on the bottom. When you times by that, you're timesing by a 0. So you're making both sides effectively 0. So you've got everything is equal to 0. So you can't times by zeros because that trivializes the whole idea of the equation. Okay, so it makes everything 0. So you shouldn't be timesing by zeros when doing any algebraic manipulation. I'm going to stop the stream there. I will write this answer up in the OneNote. Okay, but I just noticed the stream's gone over 40 minutes, so I'll stop it there. If you're interested in this answer, you can go and look up the OneNote in the link and see what the answer